Hello ma'am, my name is Suhas Mangara and today I'll be presenting my project title Email Spam Classifications using Navy Space Decision Tree and K-nearest neighbors. I chose this topic because nowadays spam emails have become one of the most common and persistent cybersecurity challenges. Coming to the next slide, email remains one of the most widely and used communication tools, but yet spam emails continue to rise and create serious risks such as phishing, fraud, malware attacks, and large-scale data breaches. As these threats become more sophisticated, traditional rule-based filters are no longer sufficient. This project investigates how machine learning can enhance spam detection by analysis and comparing three widely used algorithms. Those are Navy Base, Decision Tree, and K nearest neighbors. The object is to determine which model provides the highest accuracy, efficiency, reliability, and ultimately the goal is to identify a practical solution that can be efficiently used in real world like email filtering system. Coming to aims and objectives, the research aim of this project is to evaluate and compare the performance of Navy base and decision trees and k nearest neighbors to determine which algorithms is most accurate and efficient for email spam classifications. Basically, to achieve this, the project follows five smart objectives. First, the dataset will be collected, cleaned, and pre-processed by week 4. By week 5, the email text will be converted into numerical features like using TF, IDF, and all those things. And all three algorithms will be implemented and trained by week 7. Their performance will then be evaluated using standard metrics by week 8, and finally the best performing model will be identified by week 10. In this slide, this Gantt chart outlines the project timeline from the late November to early February, where the background study and a literature review are completed first, followed by data collections and pre-processing. TF-IDF future engineering is carried out in the December, after which the three machine learning algorithms are trained and evaluated throughout January. The project concludes with reporting, proofreading, and final submission in early February. And in this slide, we're gonna look into project scope. The scope of this project is limited to building and analyzing an email spam classification system using three traditional learning algorithms such as neighbors based decision trees and k nearest neighbors. The project focus on like text based email datasets which will be cleaned, pre-processed, and transformed using TF-IDF for the future extraction, where each algorithm will be trained and evaluated under identical conditions to ensure a fair comparison, such as peak for performance will be assessed through accuracy, precision, and recall, and such as F1 score and confusion matrices. And the project does not cover deep learning or real-time deployment, but aims to identify the most effective model for practicing spam filtering applications. And coming to the next slide, it's about the literature review. Recent research continues to emphasize the importance of machine learning in effective spam detection, where Adnan highlight that machine learning algorithms remains highly reliable with Navy base were frequently outperforming others on large text heavy email datasets, where Hussein further demonstrates that decision tree provides strong interpretability, making them high suitable for transparent and explainable spam filtering systems. Meanwhile, k nearest neighbors are discussed by Gograge, where uh, it can achieve competitive accuracy but faces limitations due to its high computational cost during intense based comparisons. These studies collectively inform the comparative approach used in this project, where recent research provides strong evidence on the importance of the effective pre-processing in spam detection, where Adnan highlighted that TF, IDF, and advanced text cleaning techniques significantly enhance classifier performance across the wide range of machine learning models, where Hussein further reframed that effectiveness of any spam classification models is strongly influenced by factors such as dataset size, feature extraction quality, and variations in email language patterns. But overall, existing studies consistently show that Navy base performs exceptionally well in based on classification tasks, whereas decision tree offers clear interpretability, and whereas k nearest neighbors provides simplicity, though through with higher computational cost, where the research gap exists in the form of limited research directly comparing to navy based decision tree and KNN using model pre-processing techniques and current spam data sets under the same evaluation and the conditions. And coming to the purpose solutions, it begins with the pre-processing the data set by the cleaning the email text, removing noise, stop words, and duplicates to ensure high quality inputs. Next, the emails are transformed into numerical features vectors uh, using TF, IDF, where allowing the models to understand text patterns effectively. When the data sets is divided into training and testing sets for unbiased model evaluation, where three machine learning algorithms are trained and tested under the same conditions, where their performance is compared using key evaluation matrices, and the system follows a simple flow like data input, processing, pre-processing, feature extraction, classifications, and final output. The proposed system follows a structured workflow to ensure accurate spam detection. It begins with the data input stage, where raw emails are collected from a reliable spam dataset. After this, the pre-processing stage cleans the text by removing noise, stop words, and inconsistencies. Once clean, the system generates a decision matrix containing key variables such as TF IDF word weights, email lengths, and keyword indicators, and special character density and URL counts. These features are are then processed through TF-IDF to create like numerical vectors. The classifications stage applies like decision tree and navy based KNN models, and finally the system outputs predictions and performance matrices. And in the conclusion, this project demonstrated that machine learning remains highly effective for the email spam classifications by comparing navy space, decision trees, and KNN under identical conditions. The study shows that navy base offers the strongest overall performance for the text-heavy datasets, where decision tree provides clearly interpretability and KNN delivers competitive accuracy with the higher computational cost. The inclusion of TF-IDF and strong pre-processing significantly enhance results across all the models. Overall, this comparative analysis identifies the most efficient and reliable algorithm for practical spam filtering applications, while also highlighting opportunities for future improvements using deep learning and real-time detection systems. To finalize the references for this project, I focused on sourcing like recent credible and peer reviewed studies published between 2022 and 2025. Selected papers that directly relate to like email spam detection, machine learning algorithms, pre-processing techniques, and evaluation methods. References such as Adnan Hussein offer contemporary insights into algorithm performance, uh, where studies like uh, Gograge and Lee provided comparative evidence across models, ensuring reliability. I also included methodological papers like Mathur and Malampati and Hegde to strengthen justifications for TF, IDF, and evaluation matrices. Thank you, ma'am, for your time and patience and engagement throughout my presentation. Thank you, ma'am.